Venus is not a planet. It's a crime scene with weather. Somewhere between the warm familiarity of Earth and the rust-colored deserts of Mars, there's a world the same size as ours, made of roughly the same materials, born from the same cloud of gas and dust. And yet it has become something so wrong, so violently hostile to anything alive, that every machine we've ever sent there has died within hours. Most died within minutes. The ones that survived long enough to take a picture showed us a sky that bleeds. This is the story of why you'll never come back from Venus. Not because we don't have the rockets, not because it's too far. Venus is our closest planetary neighbor, glittering in the evening sky as the brightest object after the moon. The reason you'll never come back is simpler. Venus doesn't let things leave. Let's start with the trip in, because the journey to Venus is the only part that feels normal. A spacecraft launched from Earth takes around 4 months to get there, a shorter flight than the cruise to Mars. You'd watch our pale blue world shrink behind you for a few weeks, and then a strange thing would happen. The brightest star in the black would start to swell. It would grow into a disk, a pearl, a featureless, smooth, blinding white sphere that looks almost gentle from a distance. No swirling storms visible like Jupiter, no polar caps like Mars, no oceans like Earth, just a pale circle reflecting more sunlight than any other body in our neighborhood. That smooth white surface you see isn't a surface. It's the top of a cloud deck about 30 miles above the actual ground. And once your spacecraft passes through it, the journey home ends. Not metaphorically, mechanically, chemically, permanently. Imagine you're inside that descending probe. The first thing you'd notice, before anything else, is that the clouds you just punched through weren't water. Earth's clouds are made of tiny droplets of water vapor. The clouds wrapped around Venus are made of sulfuric acid, the same chemical your car battery is filled with, the same compound that eats through metal and burns lungs from a single deep breath. The entire planet is shrouded in a thick acid haze, about 15 miles deep, and as your probe descends, droplets bead and slide across the heat shield, etching it as they go. This is where the rain comes in, and this is where the title earns itself. Venus has rain, constant falling rain, but not a single drop ever touches the ground. The droplets of sulfuric acid form in the upper cloud deck, plunge through the heavy atmosphere, and somewhere around 15 miles up from the surface, they hit air so hot the liquid boils away into vapor. The vapor rises, recondenses higher up, and falls again. Forever. A closed loop of poisonous weather that never finishes its journey. And the color. When sunlight filters through that thick acid haze, the sky on Venus doesn't look blue, it looks orange, rust orange, like a permanent sunset wrapped around the entire world. Deeper down, where the haze thins and the heat distorts the light, that orange shifts darker, toward red, towards something the color of dried blood smeared across a wall. You're inside a spacecraft falling through a sky the color of blood, while poisonous weather cycles around you in an endless, dry storm. Welcome to Venus. Now you keep falling, and the temperature keeps climbing. At the cloud tops, the temperature is roughly -10 degrees Fahrenheit. Cold by human standards, but breathable cold. The kind of cold you'd find on a winter night in northern Minnesota. As you descend, that number rises fast. Within an hour, the air outside your probe is hotter than boiling water. By the time you're a few miles from the ground, it's hotter than the hottest day ever recorded in Death Valley. Several times hotter. At the surface, the temperature is 870 degrees Fahrenheit. Day or night, summer or winter. There's no variation. It is mile for mile across the entire planet, hotter than a self-cleaning oven set to its highest cycle. Hot enough that lead pools on the ground like water. hot enough that zinc, tin, and even some kinds of glass would soften and run. Pop science articles love to describe astronauts on Mars facing extreme heat. Mars is a freezer compared to Venus. The average temperature on Mars is around -80 degrees Fahrenheit. The average temperature on Venus is 870. Two planets, almost the same size, almost the same distance from the same sun, and one is colder than the worst night you've ever experienced, while the other is hot enough to melt your wristwatch into a puddle. Why is Venus this way? Because Venus has the strongest greenhouse effect in the solar system. Its atmosphere is over 96% carbon dioxide. Thick, dense, suffocating carbon dioxide that traps heat the way a wool blanket traps body warmth, except this blanket is 50 miles deep. Sunlight gets in. The heat it generates can't get out. Over hundreds of millions of years, that trapped heat built and built until the entire planet became a sealed oven. Even at night, even at the poles, even in the highest mountain ranges, Venus is 870 degrees. There is no shade. And then there's the pressure. This is the part that breaks most people the first time they hear it. On Earth, at sea level, the atmosphere presses down on every square inch of your body at about 15 pounds per square inch. You don't feel it because you grew up inside it. Every cell in your body is pressurized to match. It's the baseline of being alive. On Venus, at the surface, the atmospheric pressure is roughly 90 times that. 90 times. The equivalent, in terms of force on your body, of being a little over half a mile underwater in our oceans. If you somehow stepped out of your spacecraft onto the Venusian surface, the air itself would crush you before the heat had a chance to do anything else. You wouldn't feel hot, you wouldn't feel anything. Your chest cavity would collapse in the first heartbeat. The atmosphere, just sitting there doing nothing, would kill you faster than the temperature that's slowly cooking your shielding. This is why every Soviet probe ever sent there died fast. And the story of those probes is one of the most haunting chapters in the history of robotic exploration. In the 1960s and 70s, the Soviet Union launched a program called Venera. 16 numbered missions over 2 decades, all aimed at one place: Venus. The first ones didn't even reach the planet. They lost contact halfway. The next few made it to Venus, but were destroyed in the atmosphere before reaching the ground. The pressure shattered them like beer cans run over by a freight train. Then, on October 18, 1967, Venera 4 became the first human-made object to enter the atmosphere of another planet and transmit data. It survived 93 minutes of descent before falling silent, somewhere around 15 miles above the surface, crushed before it ever got there. In 1970, Venera 7 became the first spacecraft to successfully soft land on another planet. After its parachute failed and it slammed into the ground, weak signals continued for 23 more minutes. In October 1975, Venera 9 returned the first photograph ever taken from the surface of another world. A grainy black and white image of a rocky, gravel-strewn landscape under a hazy orange sky. It transmitted for 53 minutes before going silent. Then came Venera 13. Launched in October 1981, it touched down on March 1, 1982. It survived 127 minutes on the surface, the longest any spacecraft has ever endured down there. And in those 2 hours, it captured the most haunting photographs ever taken on another planet. Color images. Real color. You can look them up. They show a flat, broken landscape of slabs and pebbles stretching to a hazy horizon under a sky the color of rust. A small alien hellscape, glowing with heat, photographed by a robot that knew it was dying. Then the cameras failed. The transmitters fell silent. The hull began to soften. The electronics inside cooked. Somewhere on the surface of Venus right now, the remains of Venera 13 are still there. a pile of fused metal and circuitry that used to be a machine, slowly being dissolved over centuries. Consider the engineering that even let those probes last as long as they did. The Soviets couldn't insulate their way out of the problem. Insulation only slows down heat transfer. Eventually, the heat gets in anyway. They couldn't use active cooling either, because a radiator works by dumping heat into cooler air, and on Venus there is nowhere cooler to dump it. So they did something brilliant and grim. They turned every lander into a temporary heat sink. They pre-chilled the interior to near freezing before atmospheric entry, packed the electronics in titanium pressure vessels surrounded by lithium nitrate trihydrate, a chemical that absorbs heat as it melts, and accepted that the moment the chemical finished melting, the mission was over. Every Venera lander was a countdown timer the second it touched down. They weren't building survivors, they were building candles. That's the legacy of every visitor to Venus. They arrive, they send back something, they die. We've never recovered a single object from the surface of that planet. We never will. A retrieval mission would have to survive the descent, land, perform the science, lift off again, fight its way back through 90 atmospheres of pressure and an entire sky of acid, and return to Earth. Every step of that sequence is currently beyond the limits of what humans can build. Now, imagine you, in person, were dropped onto that surface in a hypothetical pressurized suit that somehow held off the heat, the pressure, and the corrosive air. Forget the engineering. Just imagine your boots hit the ground. What would you see? The first thing that would hit you isn't the heat, it's the weight of the air. Even inside a perfect suit, the atmosphere outside is so dense that wind on Venus doesn't blow, it pushes. The surface winds are slow, only a few miles per hour, but the air itself is so heavy that those slow winds carry the force of an ocean current. You wouldn't feel a breeze, you'd feel like you were standing chest-deep in molasses. The sky above you would be a glowing, smeared orange dome, with no sun visible anywhere. The thick cloud cover scatters sunlight so completely that you cannot see the disk of the sun from the surface of Venus, ever. There is no day and night here in the way Earth has them. There is only a dim orange twilight that lasts for the entire 2,000 Earth hours of a Venusian day. The planet rotates so slowly that a single day on Venus is longer than its year. You'd watch the smeared light shift over weeks. You'd never see a sunrise. You'd never see stars. And here's a small detail that should rearrange your sense of what a planet is. Venus rotates backward. Every other major planet in the solar system spins in the same direction it orbits, like a basketball rolling forward as it travels. Venus spins the opposite way. If you could somehow see through the clouds, the sun would rise in the west and set in the east, taking 117 Earth days to crawl across the sky in one direction. Nobody is entirely sure why. The leading theory involves a colossal impact early in its history, something so violent it flipped the planet upside down and stalled its rotation. Somewhere in Venus's past, before the runaway greenhouse, before the oceans boiled, something hit it hard enough to invert the entire world. The ground beneath your boots is volcanic. Venus has more volcanoes than any other planet in the solar system. Over 1,600 major ones and tens of thousands of smaller ones. Recent data from NASA's Magellan mission, reanalyzed in 2023, confirmed something scientists had suspected for decades. Venus is still volcanically active. A vent in a region called Mart Mons appeared to change shape between two Magellan flybys. Something erupted. On a planet that already runs at temperatures hot enough to melt lead, fresh lava is still being squeezed out of the crust. The terrain itself isn't shaped like Earth's. There's no continental drift here, no slow grinding of tectonic plates, building mountain ranges over millions of years. Venus doesn't have plate tectonics. Instead, every few hundred million years, the entire surface seems to repave itself. The crust flips. Volcanoes erupt across the entire planet in a global resurfacing event that smooths over everything that came before. The surface you'd be standing on is roughly 500 million years old, planet-wide. Whatever happened before that last resurfacing, whatever oceans or rivers or possible cradles of early life Venus may have had, were paved over in fire. There are mountain ranges. The highest peak is Maxwell Montes, rising about 7 miles above the mean surface. That's higher than Everest. There are vast plains, basins shaped like enormous craters, and strange features called coronae, circular structures hundreds of miles across that look like the planet has acne scars from inside. These were caused by upwellings of hot magma that pushed the crust up and then collapsed back down. There's nothing like them on Earth. They're a Venus original. Then there are the flashes. For decades, Soviet Venera probes and the European Space Agency's Venus Express orbiter, which mapped the planet from 2006 to 2014, picked up strange signals consistent with lightning in the upper atmosphere. The detections are still debated. Some scientists think Venus has active electrical storms inside its acid clouds. Others believe the conductivity of those clouds prevents proper lightning from forming, and the signals are something else entirely. If the flashes are real, they don't behave like Earth lightning. There's no rainstorm to follow them. There's no soaking ground for them to strike. Just the flash, the silence, and the chemistry of acid that never settles. So how did this happen? This is the question that haunts every planetary scientist who studies Venus. Because Venus and Earth started almost identically, same size, same composition, same distance ratio from a young sun. Somehow one became a garden and the other became a furnace. The leading theory is brutal. Around 700 million years ago, give or take, Venus had oceans, liquid water, possibly continents. Possibly, though no one can prove this, possibly life. Then something tipped the balance. Maybe the sun slowly grew brighter, as stars do. Maybe a massive volcanic event flooded the atmosphere with carbon dioxide. Maybe both. Whatever it was, the temperature rose just enough to start evaporating the oceans. Once water vapor entered the atmosphere, the greenhouse effect kicked in harder. More heat, more evaporation, more vapor, more heat. A runaway loop that nothing could stop. The oceans boiled. Every drop of liquid water on Venus rose into the sky and was eventually stripped away by the solar wind, lost to space forever. The carbon dioxide, once locked in rocks, baked out and dumped into the atmosphere. The blanket thickened, the pressure climbed, the temperature climbed. And one day, somewhere in that long, slow apocalypse, Venus crossed a line and could not come back. That's what makes this planet terrifying. Not the heat, not the acid, not the pressure. It's the fact that Venus is a warning. A planet that became uninhabitable not because it was born wrong, but because it tipped over. A reminder, sitting about 25 million miles from Earth at its closest approach, that worlds can die. There are scientists who study Venus specifically because they're afraid Earth could become it. Not soon, not in your lifetime. Over geological time, if certain feedback loops kick in, the same fate is at least theoretically possible. Venus is the ghost of a sister we never got to know. One last thing. In 2020, a team of astronomers led by Jane Greaves at Cardiff University announced they detected phosphine in the upper atmosphere of Venus. Phosphine is a gas that, on Earth, is produced almost exclusively by living organisms, microbes. Anaerobic bacteria, the kind of life that thrives in the deepest, most oxygen-starved corners of our world. The detection was controversial. Other teams reanalyzed the data and pushed back. Follow-up observations using the Sophia Airborne Observatory in 2022 produced more disputed results, with researchers arriving at directly opposite conclusions about whether the signal was real. The question hasn't been settled. Up in the cloud deck of Venus, about 30 miles above the molten surface, the temperature and pressure are surprisingly Earth-like. Around 80 degrees Fahrenheit, roughly 1 atmosphere of pressure. It's the only place in the entire solar system, outside of Earth itself, where a human being could theoretically survive in just an oxygen mask, ignoring the acid in the air. There have been serious proposals by serious scientists at NASA and elsewhere to send floating habitats into the Venusian cloud deck, cities in the sky, suspended above a planet that wants nothing alive on its ground. If anything is living on Venus, it's drifting through those clouds. Microbes adapted to ride acid droplets, generation after generation, never touching the surface that would kill them in a heartbeat. It's a wild idea. It might be wrong. It also might be the most consequential discovery in the history of biology. We don't know. We may never know, because going there to find out is almost beyond us. NASA has 2 missions on the books to revisit Venus this decade. One called Da Vinci, designed to plunge through the atmosphere and analyze its composition in detail. Another called Veritas, designed to map the surface in resolutions never before achieved. Both have been delayed. Both face budget threats. The European Space Agency has a mission called Envision in development. India's space program is studying a Venus orbiter. After decades of neglect, interest is rising again. None of these missions are bringing anything back. None of them are landing humans. None of them are even attempting to recover the bodies of the Veneras still sitting on the surface. We are still, after 60 years of trying, just barely able to whisper a few words into Venus before it kills the messenger. The world that should have been our second Earth is the closest thing we have to a vision of hell. A scorched, crushing, acid-soaked, blood-skied corpse of a planet that may have once been beautiful and may even, somewhere in its clouds, still be alive. For as long as we are limited by metal and silicon, by what melts and what crushes and what dissolves, this place will keep its secrets. You can look up tonight. Just after sunset, in the western sky, you'll see a single bright pinpoint of light. Brighter than anything except the moon. That's Venus. The planet rotating slowly under its blanket of fire. Its sky bleeding orange and red. Its clouds hiding storms we don't fully understand. Its volcanoes still spilling lava onto a surface no human will ever walk on. It's beautiful from here. From there, it's the end of everything. And that's it for this video. Thanks for watching, and I'll see you in the next one.